So I guess we have all the Dummies here. No? Well, the thing is everybody's talking about Ivy render, isn't it? For the last, maybe for the last 2 years, if you have been following the Angular conferences and events, you probably have heard about the Ivy render. So I'm not going to tell you, I hope, anything new. No, I'm going to talk a lot of things. And let's see if we have time. So this is probably the most important slide. If you have to leave this session with some knowledge, this is this is my name. I'm Gerard Sanz. As she was saying, introducing me, I'm a developer advocate at AWS. Just joined recently. And you can see that I'm very busy with my cat and taking selfies. I've been talking for a while now, and this is the 121 talks. Yes. And because I'm in Malaysia, this counts as a new country for me. So this is now 29 countries. Thank you. So let's start with a small timeline. And everything started in 2016. And it was September when Angular version 2 was released. Who was using Angular at that time? Okay, very good. It's been a few years. I mean, this is in internet years, it's like an eternity. 2016. And we have the first version of the renderer. You can call it like the first version 1. And at the same time, maybe if you were using Angular, you realize that there was a big mess around the release, which was introducing ng modules. And that was around the time of the release, maybe a few weeks before, and a lot of people were trying to get ng modules working for their applications and materials. And this is important because ng modules was enable server-side rendering. And we are going to talk about renderers. So that's what I'm mentioning. 2017, so we got Angular version 4. And just to remember, this is a version that is themed around stability and performance. We got animations and the new HTTP client. We also got the new website, the documentation website that we use today. And we also get a new renderer, which is called the View Engine. Or also you will see it as version 2. Now we have in 2019 Angular version 8. And the theme is smaller, faster, and easy to use. And we have seen this theme for the last, probably for the last 2 releases. And there's few exciting developments. There's differential loading, which will release different bundles for evergreen browsers using ECMAScript 6, and a different bundle for ECMAScript 5, making it a little bit smaller. We also have changes on lazy routes using dynamic imports. So we get type checking for lazy loading routes, which is good. And that also introduces the new renderer, which now is in version 3. So this is just a small intro. We're going to talk about version 3 of the renderer. And maybe the first thing we need to ask is why we need a renderer. Who knows? Who knows why we need a renderer? Okay, well, the renderer has few responsibilities. And one of them is transforming all of the concepts from Angular, the components, the directives, the different abstractions into JavaScript code. And we don't want to implement those abstractions by hand. We just want to use these abstractions, and we want the renderer and the compiler to figure it out what's the best code to execute on the browser. So mainly, what the renderer will do is create and manipulate the DOM. And this is the main usage that you will be using. But there's other opportunities when we are using the renderer, and I'm going to mention them a little bit later. It will also handle bindings and change detection, and this is probably another thing that you don't want to do by yourself. And then, of course, because the component has, besides the template, it also has the styles and animations, it also automates these for you. So it's quite a lot of work that the renderer is doing behind the scenes. And this brings few benefits. One of them is that we have multi-platform support because of this. And this is because the renderer introduces an abstraction which is sending some instructions to the Angular compiler, and it can change the way it renders the elements. So for example, when you are changing a style, it will render different code if it's used in a mobile platform or if it's used in a browser. And you won't have to change your code. So this is very interesting for Angular developers, as they can reach other platforms. And these are some examples. So probably we are going to see a lot of examples using DOM, because it's the most common. But you can also use the renderer for web workers, mobile, desktop, and server-side rendering. Of course, that's saving you a lot of time, and it's saving you this repetitive code that I'm going to show you with some examples. And maybe an interesting benefit of using a renderer is that it can introduce performance improvements that will target different JavaScript runtime engines that you probably wouldn't use if you were doing it by hand. So how that looks? Let's see a small example. So this is just rendering a small title using the element h1. And I'm going to show you, this is not real code. I'm just going to show like some pseudocode to make it a little bit easier to follow. So imagine we compile this component and we run the renderer, let's say version 2, and we see what's the output of that. This is, as I say, is a naive implementation. This is not a real implementation. So we got these elements on our page, and we have this app.js, and this is just a function, and we call the function passing the text that we want to render. We only have this h1 with the text Angular renderer, and you can see that this can be a little bit annoying. I mean, imagine if you had to run this code manually every time you want to render an element in a template. You need to select the element that you want to change. Then we create the h1, and then we create a node, a text node inside, so it can render that title. We need to also remember the order of these different child's elements. And I mean, nobody's doing this. I mean, few people. Some of you are using this type of programming these days. This is like 20 years away. But what the renderer is doing is exactly this. Of course, it's not doing an implementation like I did here, but this is just to show you what is happening behind the scenes. That will be the output. So we just find this element, uproot, and then we just render the h1 with the text. Okay. So let's see a little bit of the evolution from these different versions of the renderer. And I have few code snippets. Maybe you can see what's going on there. No, probably not. But you don't have to. You don't have to. This is just to show you the number of lines and more or less the structure. So this is a simple application doing very similar like the rendering I was doing in the previous example. So that's quite a lot of code. This is a version Angular 2. For Vue Engine, which is version 4, we have a slightly better output. You don't need to follow the code. This is just for comparison. And if you see the last version, which is using the Ivy renderer, it's much, much cleaner. So this will have few effects in our code. It will reduce the size of bundles. It will also make debugging sessions easier because we can follow this code. It's just few lines of code. If we see the different details, you will see that it's doing a very similar job of the example that I show you. It's finding the element using a selector, and then it's adding different elements, which you can follow easily. Okay, so that's pretty exciting. I'm going to use some images from cats. I hope cats are popular here in Malaysia. Yeah, okay, cool. So let's cover the rendering pipeline. And this is the steps that the compiler and also the renderer will go through. And this is just to give you like an overview of what's going on. So let's do like a little race between the current Vue Engine renderer and Ivy. Just a small race. So we start parsing a template from our component. Then we see that we are doing different things. So on the top we have Vue Engine, at the bottom we have Ivy. So Vue Engine is creating the data related with that template that is parsing. Instead, Ivy is creating instructions. So these are high-level instructions that are going to be used to render the DOM. The next step, we see that the Ivy renderer is done. It goes straight from creating the instructions to render the DOM. So that's finished now. For Vue Engine, it's not so easy. Now it needs to go through the template, the original template, and also through the template data, and it has to interpret that and then create the nodes. So that's the turtle. So this is just an overview of what's going on. Let's see how the same example that I was covering before will work with Ivy. So this is a code. Ivy is still not finished, so some of these APIs may change, but this will be very close to what you will see. So we have some imports. We have the render component API, and this is very similar to when we were calling that app function that I showed before, that is rendering the component. One thing that is missing here that maybe you haven't noticed is that we are not adding this component to an ng module. This is now independent. So components now can be compiled independent of the module that they live in. And this will also give us some nice features. For example, we can release a component in NPM with just compiling on its own, which is not possible today. So this opening few new options. This is very similar of the example before, so it's just rendering a title with this h1 element. And this is just an extract of the output. The output is a little bit longer, but we can see a few things. One thing is the selector. This is how Angular finds the element that will be rendering the child elements. And here we can see two branches. So this is actually implementing the component template. And we have these two arguments. The first one is the rendering flag. The rendering flag is telling us which phase is going to execute. Number one is the creation of the template. And number two is change detection. So every time there's a change, it will execute the second branch. Every time it creates this component, it will execute the branch with ref and 1. And I mean, we can follow the code. It's very easy to follow. It's creating the h1 tag. It's adding the text element. And it's also closing the h1 element. And then for the change detection is adding a binding. So every time the component changes, is going to pass the title from the context and is going to re-render that bit. You can also see some interesting things. We don't know what's the text. We don't know what text is going to render. The data is not available, so it's more abstract. If we were going to see this code with View Engine, we would see the actual text for that H1 node. Okay, we are getting there. You can feel like captains of the Ivy renderer. Let's get it in. Yes, okay. Ivy renderer. So let's cover a little bit in more detail what's bringing. A little bit of context. So this is the rollout plan, and Angular has been working on Ivy renderer for quite a while now, and they released this plan. So they were working on the compiler, building all those instructions that I was showing you, and implementing all of the different abstractions available in Angular. And that was released around version 7. Then they started working on the Ivy runtime, and that was released with version 8, which was end of May this year. And the next phase that we are now into is the Ivy preview, which is the phase that we are now into. And that's going to end with version 9, which is when Ivy is going to be released and set as the default. So this is kind of the context. There are few features that Ivy is going to bring, and we can see some of these. Of course, we have smaller bundles. This is an effort of the Angular team for the past few releases, and we will see more efforts to make the bundle smaller and smaller. We have also faster compilation, and this is interesting. Some of the benefits of having the new version of the renderer is that it will be able to just compile the components. As I was explaining, Ivy is working component by component. It doesn't need the context of the scope of a module. So you can make a change in a component and it will just recompile that component without having to reveal the context of the ng module as it's doing today. So that will make compilations of large projects faster. There's also simpler debugging. We have seen that the code that Ivy renders is much simpler, so that also translates in easier debugging sessions. There's also a few improvements with the implementation that Angular is working on, and this is for the first time you will have safe type checking for the templates. Anything that is on a template, if it's not using the right types, it's going to stop the compilation. And then probably the most interesting thing for users is that it's totally backwards compatible. So there won't be any changes that you will have to do. There's some areas that are not covered, like internationalization and server-side rendering, but these are going to be covered later in later releases. So some of the features that we have available today, the debugging options and Ivy backwards compatibility, but the other options are still being worked on and are going to be released in version 9. So let's talk a little bit more about smaller bundles. So this is an Angular Hello World application, which is minified and uncompressed. And this is using version 2 of the renderer, which is the View Engine. This is now 151 kilobytes. So let's see what other options we have. If we are using the differential loading, which is these different bundles for modern browsers and browsers using ECMAScript 5, we can see that we can save some space and make the bundle smaller. If we use Ivy compatibility mode, which is enabling the Ivy flag in your compiler options, we get already a big benefit. And if we are using it with version 8, we get also a smaller bundle size. I mean, you can see that it's improving as we are adding more features from Angular version 7 to Angular version 8. But what we are going after is this bundle size, which they have found in experiments, and you can see that it's massively smaller. This is like 10 times the size of the original version. And this is the reaction in social media. I don't know. I mean, imagine the React people and the Vue people, they will get completely shocked. Because they complain all the time, Angular is massive bundle, Angular is massive, but look at this. This is smaller than anything. Oh my God, look. What? Okay, so Ivy tree shaking. So how we get to smaller bundles? The main thing that Ivy is doing is improving the tree shaking. And today it can tree shake few things. It can tree shake the templates, and that's mostly the main task for the renderer. It can also find if you are not using a lifecycle hook, and it will just remove it from your bundle. And it does the same with these different pieces of Angular, so it will take dependency injection and remove dependencies that you are not using in your code. It will do the same with listeners, pipes, queries, content projection, and also structural directives. You can probably imagine that they will be adding more of those as they get finished with other areas. So that's quite interesting. We are getting like a really improvement on the bundle size, and we will see more improvements in the future. So how that works? Well, Ivy is using what it's called the incremental DOM. And a lot of the other frameworks are using Virtual DOM, React, and Vue. And Angular is going another route. This is what Google uses internally in some other applications, and this is how it works. So we have a component that is using different features from Angular. But for example, it's not using some others. During compile time, we can see the usage of these different pieces of Angular, and Ivy is smart enough to just use those features. And when the compiler is going to create the bundle, it's going to remove, for example, the template, the binding, and also the projection. And this is the code from Angular, which is now being bundled on every component. When you run the compilation with Ivy for this component, it will save space for these different pieces. So that's going to reduce the bundle already. Of course, you need a very complex application to get the most benefit. If you only have a hello world, probably it's not going to be massive benefit, but if you have a complex application, that's going to be really good. There's another concept which is component locality, and this is when you can compile individual components and even release them. So that allows to do an interesting thing, which is incremental builds. That means that if we only change a component, Angular, the compiler, will only have to rebuild that piece, which will be really beneficial for large projects. We can also release that code because we are using that those series of instructions. We can take those and release them as NPM packages, which is really interesting for library builders and maintainers. We also have an improved lazy loading. Usually with current versions, we are having to release the whole set of features for Angular in the initial bundle. And then when we lazy load, we have all these features available. With Ivy, we can split the features because we know which components are using them. So we can make this code splitting a little bit smarter. That will also improve the initial load of the applications using lazy loading with Ivy, which is usually massive applications. So if you are using your Angular project for an enterprise, that will be something interesting to look at. There's also simpler debugging. We have seen some of the advantages from the instructions created by Ivy. And you will see that you can now put breakpoints in your HTML and also debug change detection. These are some extras because of the usage of Ivy Renderer. There's also some other benefits like a small memory footprint. Tests can also improve by just switching to Ivy. And there's some old bug fixes that get also out of the way. This is a comparison between Virtual DOM and Incremental DOM. And you can see that at the top, Virtual DOM is quite intensive. When we call the renderer function, we are executing every single component. When we run the same similar application with Incremental DOM, the consumption of memory is really decreased. If you look, we only render these components at the beginning, and then we only render the change, which is just that node number 6. So that's going to save a lot of memory consumption for Ivy rendered applications. So you can just imagine all of these features, and I want you to think about this. How are you going to use these new features available in Ivy Renderer? Is this cat from the universe looking into the night? Very good. So I just want to give you this call for action. Let's try it. We are in this phase where we are trying Ivy Renderer for different projects, and the core team is expecting people to give feedback and fix the bugs that may be on the code. So if you want to use Ivy today, you just need to run this flag. This is on the Angular CLI, so it's really easy. Enable Ivy. And if you already have your project running, you can also go into this configuration, Angular compiler options, and enable Ivy. Of course, you can do this on a branch. And the sky is the limit. You can do just silly stuff with this, like playing a pizza tune. Yes. Well, if you want to know more, there's few people I recommend from the Angular core team. Probably you know all of them. And I leave you also a small application to play. So this is a playground. You can, when I share the slides, you can go and play it with it. Maybe I can show a small demo. And it allows you to add your code. And here I just have the same example. So let's change it. Let's change this. I have a data binding. So here you can play the code, and it will show you all of the different stages of using the Ivy renderer, and you can also see the different components and the definitions. So this is a playground that I leave here for you. That's all. Thank you for listening.